Hello Chinese viewers, I am DS, a psychologist, and welcome to another episode on Channel NEET. Let's continue with our Psychometrics 101. Today, we're going to do lesson 2. We're going to talk about the mathematical concept of reliability. So in our previous lesson, I shared a very simple way of understanding what reliability is. So for reliability to really make sense, we need to have a coefficient or a number attached to it. So before we talk about the mathematical concept of reliability, we have to look at this equation. Whatever things that we are trying to measure, we will essentially have what is called the observed score. So let's say in this case, we are measuring a length and we observe from the ruler that is 15 cm. This is the observed score. If we did an IQ test and we got back the results, it says that our IQ is 114. That is the observed score. The true score is what the actual length really is. So let's say, in this case, the actual length of the line is 14.8 cm. So we have incurred an error of 0.2 cm. Where did this error come from? It could be due to Polarex error, for example. So there are a lot of different sources of error when we are taking a physical reading using a physical instrument. It could be Polarex error, it could come from zero error, sometimes it could come from a human error. For example, when we are pressing a stopwatch, our human reaction time could be the source of error. Let's look at the IQ score example. Your observed score in this case is 114, which suggests that your IQ is 114. But maybe your IQ is really 120. This means that there is an error score of 6. How did this error come about? So in this case, the error score could come from factors such as when you were taking the test, you were very tired or you did not understand some of the question. So mathematically, this is the formula for reliability. Reliability equals to true score divided by the sum of true score and the modulus of the error score. So using our example just now, the reliability of our IQ test will be equals to 120 over 120 plus modulus negative 6, which is equals to 120 over 126, which is roughly equals to 0.95. So this is the coefficient of reliability of IQ test. Of course, the more reliable a test is, the higher this coefficient is going to be. Let's return to this formula again. Observed score equals to true score plus error score, and let's do another example. So there may be many educators, such as teachers, who will set regular tests and assessment papers for their students. There are some teachers, especially from the so-called branded school, they really like to set very difficult questions. So let's say the true score of the student is actually 80 points. The student is only scoring 30. Poor student, we have an error score of 50. This is because the test is set too difficult. Of course, it is also possible for it to be the other way around. Imagine I am giving students a spelling test, but all the words that I'm asking them to spell are so easy, like play, talk, walk. Every primary 1 student could get 100 marks for it, but this is not their true spelling score. In this case, the reliability of such a difficult test is 0.62, which is still considered acceptable. I hope that this lesson has given you some idea of how to calculate reliability from a mathematical viewpoint. But in actual fact, this is only a theoretical formula for reliability. It is not useful in real life. Why? Because whilst you can measure length as a true score, you cannot obtain true score of IQ. How do I know what your IQ really is unless I cut open your brain? How do I really know what your spelling score, your mathematics score, or your English score really is? Since we will never know the true score, in practice, psychologists use other coefficients or other methods to assess reliability. So we will talk about that in our next upcoming episodes. So if you're interested to know more about psychometrics, do watch out for our next upcoming episodes. If you have not already subscribed, do consider subscribing so that we can bring you more psychometrics and MBTI. Okay, I'm going to sign off now and I'll see you in our next episode. Bye bye.